What is blockchain? Blockchain is a distributed digital ledger that records transactions across multiple computers. This ensures that each entry is secure and immutable. Imagine it as a chain of blocks, each containing data, a timestamp, and cryptographic hash of the previous block. Blockchain technology is a decentralized, digital ledger system that records transactions across a network of computers. This technology ensures that each entry in the ledger is immutable and tamper-resistant, thanks to its unique design of linking blocks of data together using cryptographic principles. Each block in the chain contains a number of transactions, and every time a new transaction occurs on the blockchain, a record of that transaction is added to every participant's ledger. This decentralized nature of blockchain ensures that the data is not stored in any single location, making it highly transparent and secure against fraudulent activities. Blockchain is foundational to technologies like cryptocurrencies and has versatile applications in various fields such as finance, supply chain management, healthcare, and more, where secure and transparent data management is crucial. Blockchain transactions are stored in blocks through a structured and secure process, which is integral to how the entire blockchain functions. Here's a step-by-step explanation of this process. A blockchain transaction begins when a user initiates a transfer of data or value, like cryptocurrency, to another user. This transaction includes important details such as the sender's and receiver's addresses, the amount of transfer, and a timestamp. Before being added to a block, the transaction must be verified. This verification is typically done by a network of participants, known as nodes or miners in some blockchains like Bitcoin. They check the transaction's validity, for instance, ensuring that the sender has the necessary balance to complete the transfer. Once a transaction is verified, it is bundled with other verified transactions to create a new block. This block also contains additional data, like a unique identifying code known as a hash, and the hash of the previous block in the chain. Each block is identified by a cryptographic hash, a unique string of characters generated by a mathematical function. This hash is incredibly sensitive to the block's contents. Even a tiny change in the block data will result in a completely different hash. The new block contains the hash of the previous block, creating a chain of blocks, hence the term blockchain. This linkage ensures that once a block is added to the chain, it becomes extremely difficult to alter, as changing any information in a block would require recalculating not only the hash of that block but also the hashes of all subsequent blocks. This is achieved through various consensus mechanisms like proof of work or proof of stake. In proof of work, for instance, miners solve complex mathematical puzzles, and the first one to solve it gets to add the block to the chain. Once consensus is reached, the new block is officially added to the blockchain. This updated version of the blockchain is then propagated throughout the network, and each participant updates their copy of the ledger. After a block is added to the blockchain, the transactions within it are considered confirmed and irreversible. This finality ensures security and trust in the transaction process, as once recorded, the data in the block cannot be altered without altering subsequent blocks, which is computationally impractical in large blockchains. The concept of blockchain was first outlined in 2008 by an individual or group known as Satoshi Nakamoto. It was implemented as a core component of Bitcoin, the first cryptocurrency, as a way to record transactions in a tamper-proof manner. Satoshi Nakamoto is the pseudonymous individual or group of individuals credited with the creation of Bitcoin, the first cryptocurrency, and the development of blockchain technology. Blockchain has now grown far beyond its initial application. The following are some examples of present-day use of blockchain technology. Blockchain is the foundation for cryptocurrencies, providing a secure and decentralized way to track and verify transactions. Blockchain enables faster and more cost-effective international money transfers by reducing the need for intermediaries. Improving supply chain management. Companies use blockchain to track the movement of goods from origin to consumer, ensuring authenticity and reducing counterfeits. Secure and efficient management of patient records, ensuring privacy and easy access to authorized parties. Blockchain assists in tracking the production, shipment, and delivery of pharmaceuticals, ensuring safety and compliance. Blockchain simplifies the process of recording and transferring property titles, making them more transparent and reducing fraud. It allows for the digital representation of real estate assets, making it easier to buy, sell, and invest in properties. Implementing blockchain in voting systems can enhance security, reduce the risk of fraud, and increase voter turnout by enabling remote participation. Smart legal contracts are self-executing contracts with the terms directly written into code, streamlining legal processes and reducing the need for intermediaries. Blockchain allows for more efficient tracking and distribution of energy, particularly with the rise of renewable energy sources and microgrids. Securely storing and verifying academic credentials to prevent fraud and simplify the hiring process. Secure digital identities for citizens, reducing identity theft and simplifying public service access. Blockchain technology is renowned for its robust security features, which are fundamental to its design and operation. These features make blockchain an appealing choice for various applications requiring secure and transparent data handling. Here are the key security features of blockchain. Unlike traditional centralized systems, blockchain is decentralized, meaning it doesn't have a single point of failure. The data is distributed across a network of computers, nodes, making it highly resistant to cyber attacks or control by any single entity. Each transaction on the blockchain is secured using cryptographic techniques. Data is encrypted using a cryptographic hash, a unique string of characters generated by an algorithm. This makes the data secure and tamper-evident. Once a transaction is added to a blockchain, it cannot be altered or deleted. This immutability is ensured by the cryptographic linking of blocks. Each block contains the hash of the previous block, creating a chain. Altering a single block would require remining all subsequent blocks, which is computationally impractical. Blockchain employs consensus models like proof of work or proof of stake to validate transactions. These mechanisms require network participants, miners or validators, to agree on the state of the blockchain, making fraudulent transactions extremely difficult. The blockchain ledger is transparent and can be viewed by any participant in the network. This transparency ensures that all transactions are visible and traceable, further deterring fraudulent activity. Blockchain uses a combination of private and public cryptographic keys to create a secure digital identity reference. This digital signature ensures the security and authenticity of a transaction. The distributed nature of blockchain means multiple copies of the ledger are stored across different nodes. This redundancy makes the system highly resilient against data loss or manipulation. Smart contracts, self-executing contracts with predefined rules, add another layer of security. They automatically enforce and execute the terms of an agreement based on its code, reducing the risk of manipulation or non-compliance. Blockchain technology continues to evolve, with ongoing updates and improvements that address potential security vulnerabilities and adapt to new threats. Despite its benefits, blockchain faces challenges. Scalability remains a significant issue, as the size of the blockchain grows over time. Energy consumption, particularly in proof-of-work systems like Bitcoin, is another concern. Legal and regulatory uncertainties also pose challenges in its widespread adoption. Blockchain networks, especially those using proof-of-work like Bitcoin, can handle only a limited number of transactions per second. This limitation arises from factors like block size and the time it takes to create a new block. This results in slower transaction times and higher costs, especially when the network is congested. It contrasts sharply with traditional financial systems that can handle thousands of transactions per second. The process of mining, necessary for validating transactions and creating new blocks, involves solving complex mathematical puzzles, which is energy-intensive. This has raised environmental concerns, particularly regarding the carbon footprint of cryptocurrencies like Bitcoin. The high energy demand also makes mining and maintaining these networks expensive. The decentralized and often anonymous nature of blockchain transactions poses challenges for regulatory compliance, particularly in areas like money laundering, tax evasion, and the financing of illicit activities. Governments and regulatory bodies worldwide are grappling with how to regulate cryptocurrencies and blockchain technology. These limitations highlight the need for ongoing innovation and regulation in the blockchain space. Solutions like proof of stake, which is less energy intensive, and Layer 2 scaling solutions are being developed to address some of these challenges. Additionally, clearer legal frameworks and regulatory guidelines could help in mitigating legal and regulatory concerns. Blockchain is expected to play a crucial role in emerging technologies like the Internet of Things, and smart contracts are poised to revolutionize legal and business processes. In conclusion, blockchain technology is a groundbreaking innovation with far-reaching implications. While it faces challenges and limitations, its advantages and potential applications make it a key player in the technological landscape of the future. To learn more and get started, check out our other videos. Make sure to subscribe to be the first to get all the crypto and financial info to set yourself up for wealth and success.